All right, so I just want to talk about this project that you received uh, today, well, Friday, with the sub. All right, just to give you an idea of what it's all about. Okay, you're going to create some data. You don't have to do an experiment. You just have to create some data. And then from that data, all right, you need to make some graphs. It isn't anything out of your abilities. All right. So we're going to try and set this up for you. All right. So basically, all right, you have a packet that looks like this, and you have a gentleman who's building a Ferris wheel. All right. All right. And basically, you board the Ferris wheel here. Okay, let me see if I can get something that works. Give me 1 second. All right, so, okay. Basically, you're getting onto it here. All right, and that's considered ground level. So that's where y is equal to 0. All right, so y is equal to 0 there. All right, it says at the highest point, the person reaches 250 feet up in the air. So realize that the person's starting there. All right, and that's the height they get to, 250. Now, because it's a circle, that means we got 250 there as well, down to the bottom. So that's beneath sea level or ground level. So basically, that should enable you to figure out an important component. All right. Find the linear speed of the rider in feet per minute. Remember, linear speed is arc length divided by time. And we can do that by r times theta. Okay, realize they're making revolutions. All right, so recall that each revolution, all right, equals 2 pi when you're calculating that. All right, so you want to have theta in terms of pi. And then realize your answer should be in feet per minute. All right, and then you're going to use dimensional analysis. All right, feet go on the bottom, miles go on the top. Boom. That'll cancel out your feet. Then you do the same thing with the minutes. Minutes is going to go on the top. Hours is going to go on the bottom. That'll cancel out your minutes. And you should be able to do that. That's just a review of linear speed as part of the project, and also to be able to get ready for perhaps the quarterly, in case that's on your quarterly in a couple weeks. All right, so that's part 1. Nothing should be new there. All right, so you don't need to do anything there in terms of that. Okay. All right, so we got all this. Sorry, I got to use. Just do this. All right. Okay, so that takes care of that. So that should be a review for everybody. Now, the second part of this, all right, during each moment of the ride, the person has an X coordinate and a Y coordinate, depending upon how far he or she is into the ride. So basically, wherever they are, all right, whether they're here, there, or there, okay, they have 2 components. They have a vertical, which is how high they are, and a horizontal, which is how far they are away. And of course, they create a right triangle. Now, the one difference from this is it's not the unit circle because this is not equal to 1. All right, so instead you got to use the radius. But however, what we can use the unit circle for, all right, is number one, how long does it take for them to complete one 360-degree revolution? All right, and it says think proportions. So they do 15 revolutions in 12 minutes. All right, so you should be able to use proportions to figure out how long it takes to complete one revolution. All right. And then you use that to figure out how long it takes to do 1/12 of a revolution. Well, 1/12 of a revolution is just going to be 1/12 of your answer there. 1/8 of a revolution, same thing, 1/8 of your answer there. And 1/6 of a revolution is going to be your answer there. All right. So basically, that's what you want to do. Shouldn't be anything bad there. Okay. You're just using, like we said, things you already know, proportional thinking. You've been doing proportions all your life. You're just going to figure out the speed and then use that along with units to get the 1. Okay, so that's all out of the way. All right, and then obviously you need to convert. All right, so that's the next part. You're going to convert. All right. So we come down here, take your first column up here. So you're taking this data and you're using that down here. So 1/12 of a revolution, for example, would be 1/12 of the degrees involved. So 360. All right, so whatever that comes out to be. All right, and that's the amount of degrees you put in there. And then remember, you're going to turn that into radians. Remember to do radians. We take whatever the angle measure, we'll call it n. We divide by 180, and we multiply that by pi. Leave it in terms of pi. All right. So again, that's something you already know how to do, is to turn degrees into radians. We've already quizzed you on that. All right. So now we come to here. Now at each of these moments, first on the right has a horizontal component and a vertical component. For the sake of connecting these to lessons already learned, we'll call the horizontal component x and the vertical component y. We'll consider x the horizontal distance away from the center of the wheel and y the vertical distance away. All right. So basically when we're doing this, that's going to be a right angle. Okay. This is going to be a right angle there. All right. That is whatever you calculate the radius to be way back in the beginning. All right. And then these are going to be different spots. So at 0 seconds, we're there. So we use our unit circle to recall that. Okay. So that's going to be x, and at 0 seconds, remember y is 0. All right. Now these other moments should look familiar. 4 seconds, which is the same thing as pi over 6. 6 seconds, which is pi over 4. 8 seconds, which is pi over 3, and 12 seconds, which is pi over 2. All right, those should be familiar from the unit circle and how we developed it. All right, so if we get rid of that and we look at it, all right, so at 4 seconds, it's pi over 6. So if we drew that out, okay, all right, if we drew that out, that angle would be pi over 6. Okay. Well, from special right triangles, there's x, there's 2x, and there's x root 3. Okay. So you're going to use special right triangles to get both the horizontal distance here and the vertical distance there. Notice it says the round, so we're not going to leave it in terms of root 3. We're going to estimate that. So whatever you get, root 3 is approximately 1.7, but you can use a calculator to do that. Then we got 6 seconds, which is pi over 4. All right. So basically that's going to be x, x, and x root 2. Again, this is not 1, but the size of the radius. You should be able to figure that out from the height of the problem. And then we have pi over 3. So now they change up. The horizontal is the smaller. The vertical is the bigger. And then once again, the hypotenuse is the 2x. And then finally at pi over 2 seconds, their roles switch. So instead of 1 radius 0, it's now 0 and r. All right, so you should be able to get all those components. All right, now next up, it says use your answers above and your knowledge of unit circle. It's not actually above, it's going to be over there. All right, so we'll clear all this out. Home, 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 home. All right, it's erasing everything. Sorry. It's taking a little bit of time. Back here, do this. Erase, come on. So just erase all this. So that's all gone. All right, so again, you're using what we worked with special right triangles. Now we come to this part. All right, so now the only difference is we're dealing in the quadrants. All right, so over here, x is negative, y is positive. So remember, all these have in common, all right, is that the numerator is one less than the denominator, which means those are all in quadrant 2. All right, and recall that means all of these values are going to be negative in there. All right, and now we come down here, 7 pi over 6, 5 pi over 4, 4 pi over 3. Now the numerator is one more than the denominator. All right, which means not only are all these x's negative, now those y's are negative as well. Until we get to 3 pi over 2. And then finally, we're at 5 pi over 3, 7 pi over 4, and 11 pi over 6. So the x's go back to being positive, but the y's remain negative. But again, remember what we did with unit circle. They shouldn't be bad. All right, you should be able to use those numbers you got there and transfer them over. All right, you should be able to transfer them over using knowledge of what we did in unit circle. All right. Okay, so that's how we accumulate the data for that, for your points. Okay. All right, then we move on to what's going to be the next page, and you see some more data there. Okay, and you see some more data there. All right, so again, notice now these are all greater than 2 pi, which means you're looking for coterminal angles. Okay, and you should be able to see the patterns right away. All right, 13 pi over 6, if we subtracted double the denominator, 6 times 2 is 12. All right, so this minus 12 pi over 6 would bring me back to pi over 6. So now you're going to use your coterminal angles. And then you'll have some more points here and there, again, some positive, some negative. All right, and then the last part of this, all right, involves graphing. All right, first graph your data points in the following graph. Let x be the time in seconds and y be the horizontal distance. So for example, when you graph, okay, we'll get this out of here. Okay, so for this graph, these are your x's and these would be your y's. All right. So that's for the first graph because it says x be the time and y be the horizontal distance. So you're going to plot the points and then connect them. When we come to this graph, now we have the vertical down here, the second page of graphs. All right. So the only difference there is the time's going to stay the same. All right. But now this is your y coordinates. Okay. So that's your y. So that's the only difference between the two graphs. The x is going to be the same, but those are your y's. All right. So there we go with that. And then we're just going to take those two graphs for the last part of this. All right. All right. And transfer these over to those. Now the difference is instead of time, they're in radians. So you got to convert them over to radians. All right. You got to convert them over to radians. All right. So there's really nothing on there you shouldn't be able to do at this point. On Monday, I'll be back in and we'll give you the first assignment for this. That'll be due Friday, October 22nd. All right. This packet in itself and all of it, you'll hand in on the 29th, and then there'll be a second page after we do a little bit more with graphing trig functions. I hope this helped. Best of luck to you. I hope you have a good weekend, and we will see you on Monday. Take care.